Hello and welcome back. At this point we have a functional but basic version of Pong. So in this tutorial I wanted to look at handling any situations where, due to the ball being under the control of the physics system, something undesirable might happen. Now, from playing the game, from just testing it a little, there are occasions where if the ball hits, say, the edge of the paddle, the top and the bottom, it can get knocked out of, so it can maybe start moving like this, up and down vertically, or it might lose, it may just start moving directly across like this. So I wanted to come up with a way to deal with any problems like these. So there are, like, as in most cases, there are a number of ways you can deal with this. In this case, what I'm going to do is I'm going to start counting the time between the ball striking the paddle, and if that becomes too long, if the time it takes for the ball to get from here to here becomes too long, it's probably stuck bouncing without any X momentum. So what we'll do in that case is we'll just reset the ball. Now, the other possibility is that it will only have X momentum, so it'll basically just bounce across the paddles and it won't move at all. And at this point, I mean, one of the players could move their paddle to let it pass and continue the game, but what we'll just do there also is we'll reset the ball, we'll just take it out of play. So basically, if the ball hasn't hit either of the paddles in a while, or if it hasn't hit either of the boundaries in a while, we're going to reset it. So let's take a look at how we might do that. So I suppose the ideal place we could put this logic is, if the ball is in play, we can do an additional check. So let's just create a method here. Counts down the time since the last paddle contact, and that'll be public, it'll be void, it's not going to return anything, and we'll call it count down time since last paddle contact. And we'll also want another method for counting down the amount of time that has passed since the ball has hit a boundary. So we'll just change this, last boundary contact, and we'll change it up here too. Now, before we start these methods, we'll want to store the amount of time that has passed. So let's just put this in, put it in functional fields here. We can make it private because it's not going to be accessed outside the ball script. So private float time since last paddle contact, and we can initialize it to 0, and we will need another field, private float time since last boundary contact. Okay, I think it might be good. Let's see, where's the method where we actually serve the ball? It might just be good to reset this now, because this is just the sort of thing you could forget very easily. Reset the time since last paddle and boundary contact. So every time the ball is served, this is the method that actually adds the force to the ball, as opposed to counting down or anything like that. We'll reset the time since the last contact to 0. So let's build that and we'll see what the fields are. So we've got time since the last boundary contact equals 0. Time since last paddle contact equals 0. Okay, and let's work on our methods now. So we'll basically want to increment the amount of time that is passed on every update. So let's do that first. Increment time since last contact. And this is paddle, so time since last paddle contact plus equals time dot delta time, or the time since the time that is taken for the last update. And we'll just finish the method. So if over a certain value reset the ball. This will require some experimentation, but we can start. Let's just start off with it. But if time since last paddle contact is greater than 5, and where's our method here for resetting? Okay, so we'll want to stop and reposition it, and stop and reposition, and where's our method here for, and handle ball serve. So stop and reposition ball, handle ball serve, and we'll pass a 0 because that's to randomize it, and that's what we'd want. So that method will handle if the ball just becomes stuck in the center or at some other place and is just moving vertically. So we might also want to handle a situation where the ball is just moving directly across and it's not changing its Y position at all. So we might want to be a little more lenient with this. I suppose the first question to consider is, will the ball hit the boundaries on each time it is hit off from a paddle, between the paddles? And the chances are it will. But in the off chance that it doesn't, I think we need to leave a little more, we need to leave just a little margin of error here. So I think we can just try 10 seconds, because if it's just moving across, it's pretty easy for the players to maintain that without, and then just leave it up to the system to reset the ball. So let's just copy this method, and we'll say time since last boundary contact, and we'll change this here. And you may have set different, your play area may be a different size. You may have applied a different amount of force to the ball, or there may be some other factors. So you're probably going to need to tune this if you've made any changes yourself. But it's fairly easy to do. So that should be those two methods, and we need them to be called every. We need to call them every frame. Countdown time since last paddle contact. Countdown time since last boundary contact. And let's just check what tags we have here. Okay. So the paddles aren't tagged and the boundaries aren't tagged. So let's add tags for these first before because we want to check the tag of the game object that the object is hit to determine, so we can reset the time since the ball has hit the paddle or the boundary. So let's make one paddle, a tag called paddle, and a tag called boundary, and let's apply these. So paddle and boundary. Okay. So what I mentioned earlier, that we were going to want to pass the collision data, this is what I had in mind. So if collision is with paddle, reset counter, and let's do that first. If collision in dot game object dot tag equals paddle, and that means it's struck a paddle, so the time since last paddle contact equals 0. Else if collision is with boundary, reset counter, else, let's just copy this, collision in dot game object dot tag equals boundary time since last paddle contact, say boundary contact equals 0. Okay, that should pretty much be it. Now we'll actually make them public now. It's very handy. It's just handy for testing. We can check that the code is working as intended. So you see, actually it won't work from just there. We need to start it from the canvas disabled, so we need to start it from here. Okay, so let's just pause it and have a quick look at what's happening here in the ball. Okay, time since last paddle contact and boundary contact. Let's check to see is that resetting. Yeah, you can see the boundaries just reset. Now let's see the paddle is 1.69 now. So let's see if that resets, and that has. So that's more or less that taken care of. Now there are other ways you could handle this. When you're putting it onto the control of the physics system, you're allowing for a wider range of actions to happen. Say if you could perhaps tell the ball to deflect at a given angle. You could maybe by controlling the transform, which is, I don't think it's something that we've done here. I think we've just used the physics system. You could also manipulate the physics. I guess if you were to, you could adjust the direction of the ball if it started, moving almost purely vertically or purely horizontally. You could adjust it. That's another way to handle it, but what may happen then is the ball may be coming in towards this player and it might just suddenly, zip off in another direction. So it's one way of solving it. You could try it if you like. So I think that's more or less all from the tutorial point this time. I think in the next tutorial, I think I'll just go and clean up the code a little bit. This one might help you give you some ideas about how you could perhaps manage code. It's not really relevant for a game that's this simple, but it may be useful to you, for something to think about if you're working in a larger game. So I'll see you in the next video.